the quantum mechanics बच्चों. All right, quantum mechanics, emerging field and little complicated to understand over here. So generally, quantum mechanics is different from the classical physics. So classical physics is based on three pillars. First one is the classical mechanics. Second is classical electrodynamics. Third one is the classical thermodynamics. Okay, so three pillars combine to form the classical physics. All right. So through the classical mechanics, if you see classical mechanics, we study the motion and forces. We have seen, we have studied the Newton's 3 laws of motion in our school. All right, laws of gravitation through the in the classical mechanics. In classical electrodynamics, we generally study about the Maxwell equation, in which we study how electric and magnetic field interact with matter, right? And it also explains the electromagnetic nature of the light as well, all right? In thermodynamics, we study the study of heat, study of energy, all right? And there are 4 laws of thermodynamics. So they are the pillars of the classical physics. But these laws in earlier 19th century, these laws fail to explain the behavior of the nature of atomic and subatomic scale, all right? Atomic and subatomic scale. So what are the elements? What are the particles at atomic and subatomic scale? Generally, proton, neutron, and electron. We already know about it. Okay. So how do they behave? They, these classical theories, they were not able to explain how do they behave at subatomic scale. All right. So here, quantum mechanics concept developed. Okay. So quantum mechanics concept developed. Quantum mechanics describes the behavior of nature at atomic and subatomic scale. All right. So within the nucleus, if you see here, proton and neutron is there, and electron is revolving around the nucleus. All right. So how do they behave? How do they exist? How do they form the composition of nature? This is explained through the quantum mechanics. Very basic. So within the they are the subatomic particles. Quantums are the subatomic particles, and quantum mechanics is the study of the behavior and nature of the subatomic particles. All right. So here I have seen here, I have written here, there are some key principles of the quantum mechanics. The first one is the wave particle duality. Okay. Heisenberg uncertainty principle that emerged, I will discuss here, that how the development in quantum mechanics took place. So we'll discuss about the how the Heisenberg uncertainty principle determined the nature of these subatomic particles. Right. We also study about the Schrodinger equations. Okay, very basic details are not required here, but question could be asked that quantum mechanics are based on which principles, that you need to understand at least the basics of it. All right. So some basic concept here, What is quanta? And quantum or photon. अगर आप देखें तो light आती है आपकी, है ना? Light come in the form of the photon. This is also called as a quantum. All right, simply. So quantum is minimum indivisible amount of any physical quantity, that is energy or matter. So अगर आप किसी भी matter से, है ना, minimum indivisible quantity means ऐसा minimum amount if you are able to extract it out, that is called as the quantum. So minimum amount from a matter could be extracted is generally electron, proton, or neutron. All right. So they behave like a quantum particle. That is what I wanted to say. Some elementary particles are also there. All right. So here fundamental particles, there are 17 in nature. 12 of these fundamental particles, they form the matter. This is also called as the fermions. And 5, they are force carriers. So whatever these matters are, bind with, there is need of some forces. And these forces are also reflected through the, some basic particles. They are called as the bosons. All right. And they together form the physical matter. And these particles behave like a quantum. These particles behave like a quantum. All right. Quantum, they follow the rules of the quantum mechanics. Okay. They are the part of the nature. They are, they together form the whole nature, and they behave like at subatomic scale. They behave like a quantum particles. All right. So whether they are photon, whether they are electron, muon, Higgs boson, all right, they all, whether they are neutrino or antineutrino, they behave like the quantum particles. Okay, quantum particles. So here, how this evolution happened. Okay, evolution happened. Why we are studying here? Because see, these particles are now going to be the tool of the technology. All right. So they are already existing in nature. So by using these subatomic particles, we are developing some technologies. Okay. For example, LEDs. All right. LEDs we develop by using the behavior and by understanding the behavior and nature of these particles. Okay. For example, we develop, so there are so many things. For example, we are developing the MRIs. All right. So for developing this MRI technology, we need to understand the behavior and nature of the particular subatomic particle. All right. Here. So that is why we are going to study about here how this, subatomic particles were explored, how these their natures were identified. All right. So first of all, if you see here, classical physics fails in late 19th century. There were three, unexplained phenomena. First one is black body radiation. Second one is the photoelectric effect. Third one is the atomic spectra. So within the atom, electron move from one energy level to another one. So there is a spectrum developed. So how these spectrums are developed, nobody was able to explain. More precisely, those three pillars were not able to explain. All right. So Max Planck came. Planck came and he explained the black body radiation. All right. Now Max Planck discovered that this black body radiation, that means heat being emitted in the form of the quanta. That heat which is being emitted is not continuous in nature. They are in the pockets. All right. That is called as the quanta. So Max Planck developed the quanta first. All right. Einstein came. Einstein developed the photons or particle nature of light. That you already know that. Then comes Niels Bohr. Niels Bohr explained the atomic spectral mystery. That means, electrons absorb energy, goes up to high level. When they come down, they emit the energy. That was explained by the Niels Bohr. All right, quantized orbits. Next come the de Broglie. De Broglie explained the wave nature of matter. All right. So Einstein developed the particle nature of matter or light or energy, and de Broglie explained about the wave nature of matter. So currently quantum mechanics are based on the discovery of three scientists: Heisenberg, Schrodinger, and Born. All right. So Schrodinger developed the wave equation. Born developed the probability. Heisenberg developed the uncertainty principle. All right. तो आपको ये जानना है, आपको डिटेल में जाने की बिल्कुल जरूरत नहीं है, because UPSC will not never ask that what is the wave equation of the Schrodinger. You just need to have a basic understanding on which principle these quantum mechanics are developed. All right. So modern quantum theory, again, modern quantum theory that is based on the quantized energy orbits. Okay. That is based on the probabilistic nature. Just a second. So modern quantum theory is based on these three scientists. They have identified the quantized orbits. They have identified the probabilistic nature of subatomic particles. They also identified the dual nature, particle and as well as the wave form of the particular subatomic particle or quantum particles. All right. So here again I tried to make you understand how the evolution happened. So first one here came the Max Planck. I told you already. All right. So Max Planck discovered the quanta, that energy emitted by a black body is not continuous. They are in the form of the quanta. Okay. Quanta or energy pockets. All right. They are not continuous. Then came the Albert Einstein. So photon strikes on a metal, it ejects the electron. Okay. It behaves like a particle nature of light. Okay. Behaves particle nature of light. ठीक है जी. Then comes the Niels Bohr. Okay. What Niels Bohr has done? Niels Bohr ने कहा कि suppose this is a atom and electron first. What electron has done? Electron absorbs energy. It comes to the higher energy orbit, and when it goes back, it emits energy. All right. So he identified there is a quantized orbit. Quantized orbit means there is separate level of orbits. Okay, separate energy level of orbits. Okay, so that was developed by the Niels Bohr. Then De Broglie came and he explained about the matter wave theory. He told that not only light, but matter also. So whatever we saw all around, okay, suppose this is a mobile phone is a matter, all right. So this is not a continuous, this is made up of small particles, small particles, that is called as a quantum. So what he explained about that not only light, but matter also shows wave nature. Okay, matter also shows wave nature. So small particles, so suppose this mobile is made up of small particles, and that particular particle also behaves or shows wave nature, बच्चों, ठीक है जी, Louis de Broglie. Then came Heisenberg and Schrodinger. Heisenberg gave the uncertainty principle, Schrodinger gave the wave mechanics. No need to understand or no need to know about the details. All right, details are not required. So modern quantum theory, I told you already about the quantized nature, probabilistic nature, and dual nature. So quantized nature was done by the Max Planck and Bohr. Probabilistic nature, Born and Heisenberg. Dualistic nature, Einstein and de Broglie. Okay. Dual nature means it is like electron and photons exhibit both wave and particle nature. Probabilistic means exact state of particle cannot be determined, only its probabilistic distribution can be known. All right. So with the larger mass bodies, it can be identified, but with in the subatomic particles, it cannot be identified simply. Okay. Probabilistic nature, quantized nature, and dualistic nature I have already explained. Okay. So here I have written the exact state of particles cannot be determined, only its probability distribution can be known. ठीक है जी, simple. So what Heisenberg has done, Heisenberg uncertainty principle, it is always in the news. What he has talked about, it is impossible to simultaneously measure or calculate both the position and momentum of a subatomic particle with absolute precision. So suppose there is an electron moving around the nucleus, all right. So and this electron is wavy in nature. So at particular moment, it is also here, all right. So at particular point, the wave is spread all around. You cannot determine the position and the speed, especially momentum अगर हम कहें broadly, ठीक है, तो you cannot determine. So wave nature को ये बताते हैं, Heisenberg proved the wave nature. कैसे wave nature है ना behave करता है subatomic particle. Like a wave, you cannot determine the correct position at particular point because it is spread all around. Okay, wave nature. He also described the particle nature. All right, particles इन्होंने कहा कि particle nature you cannot determine the exact position because to identify the position of a particular particle, you need to first excite it. Okay, so after excitation, it gains the momentum. So you cannot determine the momentum of it. All right, simple. So high mass object, I already told you, they have very high momentum. All right. Suppose you are doing the cycling, and by knowing the speed, the further position can be identified. So with high mass object, it is different position, but with low mass objects or subatomic particles, it is different position. All right. So principles of quantum technology. First one is the quantum superposition. Okay, quantum superposition. So what quantum superposition talks about? It talks about the both states simultaneously. Suppose this is the classical bit, okay, classical bit developed in the classical computers. This is the superposition bit. This is called as the qubit. Okay, so they can exist, simultaneously. Bit-based computer reads page 1, then page 2, and then page 3 of a particular book until it finds the right one. All right, sequential calculation करता है. But by using qubit, by applying this technology that is called as the quantum superposition, you can read 1,000 pages at a particular time. At once, right? At once, आप सारे 1,000 pages को एक साथ आप पढ़ सकते हो. ठीक है? That is the application of quantum superposition. Quantum entanglement means the two qubits here perfectly synchronized. इसका मतलब ये हुआ कि suppose there is a communication between two people at two different places, all right? So qubits are entangled with each other so that if somebody wants to breach it, immediately, that can be alarmed. That can be alarmed. So security keys are developed through the quantum, entanglement. High level security keys are developed. All right. Medical imaging technology like PET scans are also, developed through the use of quantum entanglement. So I told you that in the science and technology, you need not to understand the processes. You need to understand the principles and applications. That will be enough. All right, that will be enough. Here, quantum interference, if you see, so there is interference means, there are generally two types: constructive interference and destructive interference. So suppose you send a beam of light over here in the double slit, and there will be there will be several interference patterns over here. So one is called as the constructive interference, second is called as the destructive interference. They can be used in MAG scans. Okay, so machines uses brain activity in real time with high precision. Okay, it can be also used to identify a single C-reactive protein. CRP protein you must have heard during the COVID period. So even a single protein is there in your saliva, provides high precision to detect that particular protein in one stroke. All right, in one stroke. So next quantum tunneling. Quantum tunneling, Nobel Prize has been awarded in 2025. Okay, 2025 में quantum tunneling के लिए Nobel Prize award दिया गया था. So that has been in the news, and it will definitely asked in the coming examinations. Okay. So tunneling का क्या मतलब हुआ? अगर आप classical picture देखो, suppose there is an electron and there is electric field. So electron will go and hit the electric field, and it will come back. But in classical mechanics, electron we have like a wave, right? It can not just hit the wall and it come back, rather it behaves like a wave, and if it behaves like a wave, it can be appeared in another part of the energy barrier. Okay, energy barrier. So to make it more precise, here I have written that particle passes through the potential energy barrier. Okay, particle passes through the potential energy barrier. I will make you understand it properly here. So potential energy barrier like that. So if it behaves like a wave, it passes the energy barrier. Okay, and that could be explained by the wave particle duality. Here wave particle duality means it is behaving like a wave. All right. And Heisenberg uncertainty also, because see, you cannot determine the exact position of a wave. It might be on the other side of energy wall, or it could be in between the energy wall, or it can be the front side of the energy wall. All right. So these two principles are easily connected with this quantum tunneling. So the two big example here is, suppose this is a radioactive nucleus, suppose this is uranium nucleus, and uranium nucleus, there is a natural property of the radioactive material is to eject the alpha particles. That means these alpha particles are ejecting out. That means these alpha particles, when it was bind in the nucleus, with some kind of force. Now, while ejecting it out, it is opposing that force. All right, it is resisting against that force to come it out from the nucleus. So whatever force that was responsible to bind that alpha particle within the radioactive nucleus, means alpha particle has resisted that force and won over that force. All right, dominated on that force. Okay, so here I have written here, stronger nuclear force acts like a deep wall. Okay, trapping alpha particle inside. Now there is a certain probability that alpha particles wave function exists beyond the energy barrier. That means when this alpha particles adopts the property of the wave, it can eject out from the radioactive nucleus. Similarly, if you take the example of sun, right? Sun, there is within the sun there is a nuclear fusion of proton, but proton having same charges and they repel each other. All right, repel each other. So that repulsion force is acting like a barrier. So whenever these H plus has to combine, they have to cross that barrier. Quantum mechanics also explain about how nuclear fusion happens in stars. All right. नेक्स्ट है हमारा क्वांटम कंप्यूटिंग. क्वांटम कंप्यूटिंग इज बेस्ड ऑन द क्यूबिट्स. ऑलराइट, qubits can be there are individual atoms, individual photons, single electrons, but in classical bits, in classical computers, we see the transistors. Okay, we see the transistors where the electricity passes, and these transistors open and shut as per the command given. But in qubits there is no physical unit. They could be a single electrons, they could be the individual photons, they could be the loops of superconducting wires. All right. So physical units may not or may be or may not be there in the formation of qubits. All right. How do they work? There are, again, I already told you, there are superposition, entanglement, quantum interference, and quantum parallelism. Superposition mein, I have written the example. Quantum MRIs can detect individual protein. Okay. So there are layers. Suppose you are doing the MRI of your hand. There are so many proteins in your hand. So whatever the desired protein you try to find out, that could be easily detected by the quantum. Presently, there is no technology like that, right? But quantum computing computers can do that. Okay. Here entanglement, I have already explained the quantum key distribution to you. Quantum interference, already told you about the constructive and destructive interference. When constructive interference is there, signals will be boosted out. When destructive interference is there, signal will be cancelled out, and hence the more precision in the MRI or any scanning technology can be made by the help of the quantum computer. ठीक है जी. Next है quantum parallelism. Quantum parallelism का मतलब you can identify. Suppose there are 1,000 vehicles in a city. So for each vehicle, by the using of quantum computer, the fastest route of the those taxis or those vehicles could be given at one particular time. Different routes, all right. Different route can be suggested by the quantum computing. Okay, that will be used in the GPS technology. So bits and qubits already explained. Physical sense में bits क्या है? They are transistors. Transistors हैं. They are made up of electricity flowing through the switches called as the transistors. All right, and there are so many transistors in the computer. So physical sense में bits, or traditional computers में we use bits, and qubits we use in the quantum computers. And qubits could be any could be made up of any subatomic particles. They could be individual electrons. I already told you they could be individual photons, right? So capacity, if you talk about capacity of the bits are linear, and capacity of qubits are exponential, all right? Multifold increment in the capacity. Okay. All right. Rest are the very basics. I already explained you 0 and 1 bits could be either existing in the 0 or 1, but in the qubits they could exist both 0 and 1 and or in between 0 and 1. Okay, I have described here the quantum computing and classical computing में क्या difference है, advantage and disadvantage. You can easily study it off. So modern day usage of quantum physics, okay, that could be the part of your mains answer. The first one is smartphones and computers, okay, led to the creation of Gates. MRI machines, I already told you that how MRI identify a particular protein from your body, despite there are more than 20,000 kind of proteins in your body. Laser and barcodes, GPS navigation, already told you, quantum precision. SSD storage, if you see here, so SSD storage, या pen drive, what do? They utilize the technology of quantum tunneling. Wow, how? USB drive, okay, USB drives जो होती हैं, वो डेटा को जो है स्टोर करती हैं, राइट, बाय द suppose this is a USB drive, okay, suppose this is USB drive, okay. अब इसमें आप जो है बच्चों, इसमें आप USB ड्राइव है ये, आप इसको कंप्यूटर से कनेक्ट करते हो और डेटा जो है इलेक्ट्रॉन के फॉर्म में आता है इसमें, ठीक है जी, इलेक्ट्रॉन के फॉर्म में डेटा आता है, यहाँ पे स्टोर होता है, ठीक है. सो इलेक्ट्रॉन हैविंग नेगेटिव चार्ज, दे मस्ट repel each other, but despite that repulsion force, they are getting stored in the form of the data, okay. So that behaves like a quantum tunneling. Quantum tunneling, I already told you what is the quantum tunneling. Quantum tunneling means the subatomic particles or atomic particles, they are crossing the barrier, repulsion barrier. So they are, despite they are having a same force, charges, that is creating the repulsion force, but still they are being stored at a particular place by using this, quantum tunneling method. Okay, so quantum tunneling is a method through which this pen drive storage could be easily explained. Simple one. All right.